On September 25, after the Chinese rocket force successfully launched the Dongfeng-31AG intercontinental strategic missile into the South Pacific Ocean, all kinds of rumors have emerged again in the past week. Some say that the Dongfeng-31AG intercontinental missile uses the Qian Xuesen trajectory and is simply impossible to be intercepted by the U.S. missile defense system. Some say that compared with the U.S. Minuteman III and Russia's Sarmat, the Dongfeng-31AG intercontinental ballistic missile is a mobile intercontinental ballistic missile. Every place in China's 9.6 million square kilometers of land can be used as a launch site, and its survivability is far stronger than that of intercontinental missiles of the United States and Russia. There are even some who have simply brought out the non-existent model like Dongfeng-51. The appearance of these strange remarks proves that ordinary people really have too many misunderstandings and various stereotypes about intercontinental missiles, this national heavy weapon. Therefore, today let's do a little science popularization and answer the above questions. First of all, the so-called Dongfeng-31AG intercontinental ballistic missile uses the so-called Qian Xuesen trajectory. Obviously, this is applying the performance of a typical hypersonic vehicle to the Dongfeng-31AG. In fact, whether a strategic missile has hypersonic gliding performance depends on two characteristics. First, look at whether the shape design of the strategic missile has the aerodynamic shape design of a typical hypersonic glider that must have a high lift body. That is, using a head double cone or a complex multi-curved waver-eyed or warhead design. These two aerodynamic shape designs have good lift-to-drag ratio performance to ensure takeoff and glide in near space. Second, look at the flight trajectory of the strategic missile. The trajectory of a hypersonic vehicle is still very different from the typical ballistic trajectory of an ordinary strategic missile. There is a very typical trajectory characteristic of downward pressure, takeoff and glide, longitudinal oscillation and lateral side slip. At the end of the flight, complex maneuvers such as variable distance barrel rolls can also be performed. Only those that meet these two performance characteristics are typical hypersonic vehicles. Judging from the test launch of the Dongfeng-31AG intercontinental strategic missile this time, after the missile is launched, the rocket force took clear photos and released them. It is clear at a glance on the high-definition photos. The shape of the Dongfeng-31AG strategic missile is a typical cone. It is obviously different from the Dongfeng-26 strategic missile or the Dongfeng-17 tactical missile. It is not the double cone or complex multi-curved waver-eyed or shape that a hypersonic vehicle has. Analyzing the trajectory of the Dongfeng-31AG after it is launched, the no-fly zone delineated by the International Civil Aviation Organization is also clear. After the missile is launched, it flies in a typical parabolic trajectory and does not have the typical trajectory characteristics of high-altitude downward pressure, takeoff and glide, and maneuvering and orbit changing of hypersonic vehicles. Therefore, the Dongfeng-31AG intercontinental ballistic missile does not use the Qian Xuesen trajectory. Essentially, it is not a hypersonic vehicle. Since the Dongfeng-31AG intercontinental strategic missile is not a hypersonic vehicle, what about its penetration performance? In fact, the penetration of intercontinental ballistic missiles is an extremely complex issue. It not only relies on the maneuvering and orbit changing of hypersonic vehicles to penetrate, but also implements penetration through passive and active jamming methods. The so-called active jamming method is to install an electronic jamming transmitter on the missile payload section. Noise jamming or deception jamming can be used to block the fire control channel of land-based fire control radar or display multiple false targets on the fire control radar to cover the penetration of ballistic missiles. The so-called passive jamming method is to install multiple decoy warheads in the missile payload section. Of course, some of these decoy warheads are lightweight decoys, and some are heavy centroid decoy warheads. The former is mainly a balloon coated with metal powder, which can only simulate the missile warhead in outer space without aerodynamic resistance. The latter is a corner reflector with a certain weight. In the warhead re-entry stage, it can simulate the radar and aerodynamic characteristics of the warhead. If a ballistic missile wants to ensure its penetration effect, it often needs to have multiple penetration measures at the same time, such as installing a radar jammer on the missile, installing lightweight heavy centroid decoys, etc. In general, the penetration of ballistic missiles is an important aspect in the ballistic missile system engineering, and it cannot be described by a simple Qian Xuesen trajectory. So, how should we understand that the Dongfeng-31AG can be launched anywhere on China's 9.6 million square kilometers of land and has stronger survivability than the fixed intercontinental ballistic missiles of the United States and Russia? In fact, this is a typical misunderstanding. The storage, deployment and use of strategic missiles are regulated by a complete set of regulations. Judging from the procedures of ballistic missile body preparation, outbound inspection, and loading and departure, a ballistic missile needs to be extracted from the storage depot and undergo corresponding technical inspections before it can be allowed to leave the depot after departure. According to the provisions of the Missile Force Firepower Plan, it is necessary to occupy the basic position. If the basic position is covered by enemy nuclear strikes, the missile reserve position needs to be activated. After re-occupying the position, the missile launch operation procedure can be started. The operation procedure for mobile missile launch is not so easy to implement. After occupying the position, the missile force must immediately start the missile element preparation operation and calculate the missile launch control parameters. This work includes measuring the missile's geodetic basic elements, missile firing elements, missile aiming elements, missile detonation parameters, etc. The prerequisite condition is to carry out geodetic leveling operations. If the missile is launched on a preset position, then the geodetic elements are often measured in advance and can be directly input into the fire control computer. If the missile is launched in an unfamiliar area, then in the missile element preparation operation, the measurement of missile geodetic elements must be added, and correspondingly, the missile launch preparation time is extended. Therefore, in terms of ballistic missile launch support, the missile force will often tend to pre-establish multiple preset launch positions that have undergone geodetic tie-ins and establish geodetic reference points to ensure that when the ballistic missile conducts firepower strikes, it can quickly occupy the launch position where the geodetic elements have been measured to. In shorty, the missile can be launched quickly and shorten the time for implementing nuclear counterattacks. This also determines that even the Dongfeng-31AG with unconstrained launch capability cannot be launched anywhere casually. The launch method with the highest efficiency, the shortest preparation time, and the best ability to meet the objective requirements of nuclear counterattack operations is of course still to launch strategic missiles using preset positions at the same time, for mobile launch and fixed launch. In fact, there is no such statement that the survivability of the mobile launch method must be high and the survivability of the fixed launch method must be low. The key depends on how to play the game from the perspective of mobile launch methods. Mobile launch methods cannot be completely separated from the base and run around with missile launch vehicles everywhere. The missile launch vehicle always needs maintenance. People always need rest. And the missile also needs to be inspected after being jolted all the way on the launch vehicle, to ensure that the launched missile does not fail. Moreover, if you drag the launch vehicle and run around and are photographed by others or are attacked by enemy special forces, these are all completely possible things. Therefore, the deployment methods of the so-called mobile missile launch vehicles are greatly restricted in many cases, judging from the situation of the Russian strategic rocket forces. In many cases, Mobile intercontinental missile launch vehicles are usually deployed in fixed positions in peacetime. When the combat readiness level is changed, they start to move according to the predetermined patrol route and transfer between multiple predetermined positions according to the ballistic missile force plan, and of course, the most core is still the missile technical position. In order to ensure that the missile can be inspected and repaired at any time and ensure the effectiveness of nuclear strikes at the same time, there is no such statement that the battlefield survivability of fixed missile silos must be worse than that of mobile launch vehicles. It's very simple. As we mentioned earlier, missile mobile launch vehicles are not always in a mobile state. The deployment method it adopts should be more similar to being fixed in peacetime and moving when the combat readiness level is changed. In the event of an emergency nuclear strike, a sprint launch method is more likely to be used to carry out a nuclear counterattack before the nuclear warhead lands. So, in this case, is the mobile intercontinental ballistic missile launch vehicle relatively more fragile? On the contrary, intercontinental ballistic missiles launched from fixed silos often use a strongly fortified underground silo design, for example. The most typical one is the USMX intercontinental ballistic missile, which uses a strongly fortified underground silo with a compressive capacity of 5,000 psi. The damage resistance design of such silos includes, but is not limited to, using high-grade concrete to pour the silo barrel, using high-strength alloy steel as the framework and manufacturing the silo cover, and using active-passive seismic and damage resistance designs when such an underground silo is facing the ground burst mode attack of the Soviet Union's 550,000-ton warhead. As long as the warhead falls at a distance of about 200 meters from the silo can basically be ensured to be safe. Judging from the strike accuracy of existing intercontinental ballistic missiles, there are very few intercontinental ballistic missiles that can achieve an accuracy of 200 meters. Therefore, even if the enemy uses intercontinental missiles to directly strike the silo, it is very difficult to directly destroy the silo. And if the enemy uses a large number of warheads to destroy the silos, there will be much fewer warheads used to destroy mobile missile launch vehicles and social wealth. In nuclear games, it will obviously be in an unfavorable position. Therefore, in this way, I believe everyone is very clear whether the Dongfeng-31AG intercontinental strategic missile has used the Qian Xuesen trajectory, and what are the advantages and disadvantages of the mobile launch and underground silo launch of intercontinental strategic missiles.